Hey guys, David here and welcome to another video. It's finally time. I'm gonna tackle this humongous mess that is inside of this electronics cabinet. Just kinda got started and then realized I have way more stuff than I initially thought. It just kinda continued, not really having any sort of concrete plan, and well, you cannot find anything in here anymore. It's probably humongous fire risk, and I actually have quite a few other things that I want to add to it. So it is time to rip everything out, start over, this time slightly more appropriate. So what I did is I went to AliExpress and bought a crap ton of different semi-proper electronics stuff. I'm gonna do it all with DIN rails, so I got a bunch of DIN rail relays, got some power supplies, a bunch of connectors, a bunch of wires and crimping tools and everything. The whole thing cost me over $200, but I think it should hopefully be worth it. So I can redo everything. I can now properly hook up the spindle, so I can turn it on and off and control the speed of it through the software. I'm also going to hook up a solenoid valve to the cooling system, so I can turn on the air blast for the cutting part and then have it automatically be turned off. That should be really nice and make it a lot easier to work with. Now, if you haven't seen the last video, I did actually use this machine in this stage to cut a real part for my Cryo PC, so I'll have that linked up in the card and linked down below if you haven't checked it out already. So the machine is working, but especially having to reach into the electronics cabinet with a bunch of live wires to turn the spindle on and off was not exactly ideal. So that should all be fixed now. So how about we just kind of cue a time lapse of me disassembling everything, and then when I kind of figure out where everything goes, I'll go ahead and explain what I'm connecting how and how that's going to work. But before that, just one last quick thing. I want to give a big thanks to PCBWay for sponsoring this video. They make super high quality PCBs at a very affordable price. So if you're a hobbyist like me, you can design your own PCBs. They could be up to 2 layers, 10 by 10 centimeters, with silk screen and everything, looking very beautiful and professional. And you can get 10 pieces of them made for just $5, which is absolutely a steal. And meaning that there's no more barrier to entry for creating your own beautiful PCB project. So make sure to go check out PCBWay, linked down below. Alright, so I have gotten started with some of the wiring. You probably saw a quick time lapse. I have forgotten how long it takes to wire everything. You can see already a bunch of wires, but there still is a crap ton to do. I have been back to the apartment and gotten the schematics that I forgot there last time. So now I can actually properly wire up the spindle stuff, as I now once again remember how I had intended that. Has been quite a while since I ordered these parts and did all the thinking out of how it's going to be wired up, so I had to kind of jog my memory again. But I did this little diagram here. You probably can't see it very well here. But essentially, I have these two double relays, as I've already mentioned, to control the spindle. Now, originally it had this switch here. It's a 3-position switch that controls between off, forward, and reverse. Now, there is actually quite a lot going on with this switch, and it took the manual plus a bunch of manual kind of figuring out to understand everything that is happening here. Essentially, what this does is, for one, it turns on the spindle if it's in either reverse or forwards direction, but also it switches the wire pairs, depending if it's forwards or reverse, to actually physically change the polarity of the motor and make it go reverse. Now, to emulate this with relays, I have one double relay here for the direction, and I'll put a schematic here on screen where you can see that I basically have the common pin going to the two wires of the motor, and then I have the normally closed of one connected to the normally open of the other, and vice versa, and these two are going to my input. And then switching between the two states of the relay, I can then have it basically switch the two wires around. And then the second relay just disconnects the spindle from power basically, and make sure that the contactor does everything that it is supposed to. One thing that is actually quite a lot simpler than I originally thought is the speed control. Now, the way it worked is it just had a potentiometer that you would turn to adjust the speed from, like, on the low end, maybe like 500 RPM to 2300 RPM or something like that. Now, the way that a potentiometer works, if you don't know, it's a variable resistor. If you connect, it has 3 pins, and across the 2 outer pins is always the same resistance, and then the middle pin basically you can adjust in between those two. And the total resistance between the middle pin and left pin and middle pin and right pin always adds up to the same. And if you then connect power and ground to the 2 outer pins, at the middle pin you can basically freely adjust the voltage in between those two. That's what is called a voltage divider. And using that, you can then send a very precise voltage that you can adjust with this knob to the controller, which then turns this into all the signals that the motor needs to turn faster or slower. Now, to emulate this, the breakout board for the Ethernet smooth stepper actually has basically a digital potentiometer integrated. I can feed positive and negative reference voltage, and then on a different pin I can, by setting the speed of the spindle inside of the controller, set a voltage in between those two input voltages. This is very convenient, as it means I can just directly connect the wires that went to the potentiometer to the breakout board, and I'm done. Now, this just kind of crudely sets the speed to roughly the right speed. If I tune it in the software that the minimum and the maximum is correct, I can do that by measuring that, then plop it into the software. And then if I want something in between, it just kind of extrapolates that and goes for it. Now, while this works good enough, it kind of gets you in the ballpark. If you then engage into the workpiece, the machine does slow down a little bit because, well, there's more resistance, so the motor slows down. Ideally, you would be measuring the speed of the motor and then adjusting the power depending on that to get exactly the RPM you entered. To do that, there is an optical encoder on the motor. It's just basically a light that has a disc with a bunch of holes, and this light and receiver on the bottom, if the disc passes through and it is at a hole, then it receives light and gets a signal, and if it's not at a hole, it does not receive a signal. And then when this disc spins, you basically get a pulsed signal that represents how fast it is spinning. And using this signal, the controller can then adjust how fast it needs to spin. Now, the default controller did not implement that, as far as I can tell. It just used this signal to display the RPM on a readout, but it did not adjust anything dynamically. There is supposedly a way that I can have the Ethernet smooth stepper take that signal and have it adjust the speed that it outputs to this pin. However, the documentation for it is very, very basic and just kind of says, yes, it is possible, but it doesn't really tell you how to do it. So I need to do some more experimenting, some more figuring out. I found some people trying to do something online, but there is really not a lot of information, especially not for Mach 4. But for now, I'll just leave that disconnected and then hook that up at a later date when I have time for it. As it works like that without, and I can very easily just add that in later. So I believe it is time for me to do the rest of the wiring, and I guess for you that means a time lapse. Alright, so I think everything is hooked up now, and I'm gonna plug it in for the first time and then turn it on. And I guess just in case something happens, I'm gonna keep the camera rolling. Alright. That's not too bad. Alright, not quite turning on and off the light, or it might be the coolant now, I'm not sure which way around it is. Well, it is turning on and off on the control board. The relay for it is not. I'll have to investigate that. Alright, so figured out why some of the stuff was not working for the coolant in the light. Turns out that these I/O pins here, they are referencing to 24 volts, and then if they're on, they're not connected and like connected to ground, and if not off. So I just had to swap it around instead of to ground to 24 volts as the reference. That was a quick fix. But then I was trying to figure out why my spindle relays were not working, and it turns out that I messed up the pinout, and I thought the common pin was in the middle and then normally closed, normally open on the side, but since it's only labeled with numbers and not the more useful terms, I just messed that up, and the common one is actually on the left, and normally open, normally close are the two on the right, so we gotta swap around some pins to make everything work there. Alright, so after a lot of back and forth, it looks like I've finally figured out what the problem was. Well, the main problem is that these two relays I got are way too fancy for what I'm doing and not intended for it at all. What in the end finally led me to kind of figure out what was happening are these two diagrams here. And at first I was just disregarding them because, well, they're weird diagrams, not much labeled at all, but that together with what I was measuring led me to find out that the way these relays actually work is that the two output relays are not just directly connected, they are kind of in a way independently controlled. And the input, which I first was confused about, there's a positive, a negative input, and a switch input. If you send a pulse on the switch input, then it switches into the next state. That's quite confusing, but then first, depending on how you've configured it by connecting B1 and P2, which in all the examples is left disconnected, which confused me even more. But it turns out if you
bridged B1 and B2, you just turn both of the outputs on and off. With each time you send a signal on the switch input, you turn it on, the next time off, on, off. Like, it's intended for like lights and light switches. That's where it makes a lot of sense. And if you don't have it connected, you first turn one on, then the other one, then both, and then none. Now for my purposes, this is completely useless. The signal that I get is on signal for when it's supposed to be on, and no signal for when it's supposed to be off. But the way that I get around this is, because these are actually even more fancy than I thought. If you switch like to the switch input to a specific state, then disconnect the mains power and connect it back, it remembered which state you were in. I hope this works really well, because the workaround that I have now is that I bridged B1 and B2 to be in the state where both outputs are synchronized, which is what I want. And then I just manually bridged the switch and the positive while it was on to get into the on state. And now I'm just disconnecting and connecting kind of the main power to it, which then both gives it power, and because it's remembered the switch state, it goes into the on state directly. So if I now press spindle on, then it will work. And reverse also works the same. As you were able to see, it lights up more or less lights. While I still need to get some tape to make sure that the solenoid actually doesn't leak anymore. It's leaking quite a lot of air right now, but it still works, and I've hooked up a button inside of the software so I can test it, and right now it's off. Can play around with that all day. But it's nice, the solenoid works perfectly, and the light I can now also turn on and off, and it's now not connected to any coolant pin anymore, but a separate output pin, and I've configured that correctly. So that should be nice. So one of the more interesting things I found out when replacing one of the limit switches that I might have accidentally broken, and then I kind of took it apart a little bit, since, well, that's what I do with broken stuff, and I figured out that this screw in the back there is not to open the thing, but it's actually a knob for a potentiometer. And that made me thinking that, like, I was always disappointed on like how late these would actually indicate. Like, the description on AliExpress had a much greater distance than the activator for me. Now I put that down to, well, bad quality or something, not whatever, but it turns out that the screw here in the back is actually to adjust the distance at which they trigger. Who would have thought? That makes so much sense. So just to quickly demonstrate, this like the cross light is now fairly far away from the limit switch. Let me quickly measure so I can give you a number. So it's about 13 millimeters maybe away. Now that's even a bit farther than I would want to trigger it, but just to demonstrate, I'm gonna turn the screw in the back, and then you can pay attention to the light. When the light turns on, it has triggered. Now you see, it is triggered at this point, and now it's not triggering at this point, but if something is any closer, then it does trigger. So I'm gonna adjust all these switches to trigger quite a bit further, and then I'm gonna see instead of mock if there's any way of, like, right now when it's homing, it just goes to the switch until it finds home, and then does like a dead stop, which makes sense if you consider the homing switch as the like 0 point. but maybe I can do it so that it maybe goes a millimeter farther and can it decelerate a little bit, and maybe I can this way even do the homing a bit faster and then check a second time. Maybe there's something in there to configure. I kind of doubt it, but in any case, I'm gonna do it further away. So I'm gonna actually move the switch back a little bit, as I don't want to trigger here. I have like a whole centimeter of travel left. This is just gonna, I don't know, give me some more distance, some more peace of mind, and less chance of crashing into it if I go a little bit further. Alrighty guys, I really hope I was able to edit all of this mess into something that is at least slightly enjoyable and informative to watch. It has been quite a roller coaster of different things everywhere. Turns out not everything is as easy as you might think it is, and everything takes 3 times longer than you plan on. But what else is new? Now everything is pretty much all done and hooked up now. You can see the electronics cabinet is closed, and I was actually using the mill, so that means that I did something right. I did not have to fumble around with high voltage wires anymore just to turn on and off the spindle. I've hooked up the lights and everything again, and for the most part everything works nicely. Now there are still some areas that I need to tweak. For one, I put a lot of effort into this interface, but it's just horrifying. So I will either look online if I can find something I like and modify that, or do one up completely from scratch. I'll have to get a bit more familiar with the screen editor, but I've kind of added an extra button for the mist and stuff like that. But there are quite a few things I really don't like about the interface. Maybe I'll do an extra video, probably not. I'll see. But how about I take you on a little tour of my electronics cabinet. To get inside, all you need to do is use this highly sophisticated key to turn this very sophisticated lock. And then you can open it up. Sorry for the noise. Do my best to edit it out, but there are some fans in there and there is just some noise, and I want to show it to you with all the lights on and not everything dead. So, as before, I have the Ethernet smooth stepper with the MB2 breakout board here in the middle. That's the brains of the operations. It's connected via Ethernet here to my control tablet, and you can see a bunch of lights that just indicate all the inputs and outputs and their states. Here in the bottom I have the inputs from the input signals, and I was gonna have the inputs from the alarm stages of the motor drivers, but for some reason, even though when I crash the machine, the red light blinks, but no signal is coming out of the alarm outputs. I'll probably have to configure that somehow with an interface that I don't have, so for now that's not hooked up. But speaking of motor drivers, that's the muscles of the operation. It gets the step and direction signal for each of the 3 axes here, and that gets fed into here. The way that the logic on this one works is that I have positive connected to all of them, and then I'm pulling these pins negative. It's kind of everything is backwards on this breakout board, where it's like the default state is 24 volts, and then to turn it on you pull it down to 0. It just takes some getting used to, but it really doesn't matter. And then this amplifies the signals for my motors to do that. It also has encoders that come back, and these have saved my bacon so many times, because if your motor draws a bit too much power for whatever reason, they're just gonna turn off and don't continue. And I've crashed this machine more than once, mostly due to stupidity, and every time they turn off immediately before anything could get damaged, and then you reset the whole machine, and then make sure to go the right way to begin with the next time, and everything works normally again. They can also protect you for like lost steps and stuff like that, but I'm not using it as much for that at the moment, at least I don't think so. But it's also quite nice because they dynamically adjust the power for the motors, so that theoretically it's not cooking the motors if it's not necessary, but still supplies enough power. These ones are hooked up to this power supply here, which is 60 volts and a crap ton of amps. I have this thick power wires here through this distribution coming from here. That power supply does nothing but supply the power to these modules. Then I also have a 24 volt supply up here that supplies power to all the logic systems. And I have a 12 volt supply here that supplies power to the lights, which run on 12 volts, and a couple other small things that also need 12 volts, like for example the PC cooling fans that I have here to keep some air flowing through this enclosure and not have anything overheat. Now up here you can see the whole debacle of the Spindle Control. Here this big thing is the main speed controller. It's basically your VFD. There are some knobs on there to adjust it more, but I need to get some sort of RPM meter to be able to perfectly dial it in and adjust everything. I'll do that at a later date. You also have the filter here for it and the big contactor which turns it on and off. Here I have the two relays that I talked to you earlier about what the problem is with these. Next time I'll definitely not get fancy lighting relays anymore, but just more standard ones. But with the workaround it works. I hope that it remembers that. Also here, this little thing is a soft starter for this power supply. Now if you got a high quality power supply, you do not need a soft starter for it. But this one kept blowing my fuses when I turned it on. So I added a soft starter to it that just limits the amount of current it draws in the beginning, and then after a couple of seconds connects through and basically is invisible to it and doesn't do anything. Also here I have a bank of relays. Right now I'm just using two of them, one for the light and one for the mist coolant, but I have three more that are already wired up to the controller board, so I can very easily add anything in the future that I might like. This power meter here in the middle gives me the power draw of the spindle. My intention is to kind of have a way to monitor the loads, but the way it works is just kind of cycles through volts, amps, power and total power consumed, so it's not all that useful, but maybe I can hack it in some way to always display watts, or otherwise I could just have to kind of wait a little bit. But it's in there and it's certainly not hurting anything. And with that I think the tour is complete. Now it's still not ideal. There are a couple of things that I would point out that are certainly not ideal the way they are hooked up and could be done better, but if we flash a picture here of how it looked before, I'm very happy with how it turned out, and definitely don't have to be ashamed anymore to show off my electronics cabinet. And with that, I want to give once again a big shout out to PCBWay for sponsoring this video. And for you guys, thanks for watching. I'll see you next time. Make sure to like, comment, subscribe, all that good stuff. Bye!